So in this next example, use Maclaurin's theorem to expand tan pi over 4 plus h up to the term in h cube. Hence, determine the value of tan 46 degrees. Remember, Maclaurin series can only expand in ascending powers of a given variable. If the variable is x, it is ascending powers of x. If the variable is y, it is ascending powers of y. If the variable is h, it is ascending powers of h. So it is not a case of Taylor's theorem whereby when you have f of x plus a, then you start from f of x, then plus your h power 1 over 1 factorial, f prime of x, then plus your h squared over 2 factorial, f double prime of x. This is a Taylor series expansion of f of x plus h. Are you seeing that? Meaning Taylor series is what uses this, but we are dealing with the Maclaurin's theorem. Are you seeing that? So Maclaurin's theorem, it is no longer x plus h, it means h is the variable. Are you seeing that? H is that? H is the variable. So this is what it means. We are expanding a function f of h. Are you getting that? We are expanding a function f of. So if you expand the function f of h, what do you get? Are you getting that? If you expand the function f of h, what do you get? So for you to expand f of h, you start from f of a, isn't it? Yes. So we have f of a, then plus, you leave a space, f prime of a, then plus, you leave a space, f double prime of a, then plus, you leave a space, f triple prime of a. So once you've done that, when you have f triple prime, that is where you have the h cube, isn't it? So it means in this first part, when you differentiate it for the first time, that is h minus a raised to power 1 over 1 factorial. Are you seeing? Yes. When you differentiate for the second time, that is h minus a squared over 2 factorial. If you differentiate it for the third time, that is h minus a raised to power 3 over 3 factorial. You see, they've used this variable to confuse you in that case of a Taylor's expansion of x plus h. Are you seeing that? Don't confuse it with that Taylor expansion. That is not Maclaurin's, isn't it? Are we together? Yes. That is not Maclaurin's. Taylor is where now where you have f of x plus h. This is the Taylor, where you have your f of x plus your h to power 1 over 1 factorial x. Are we together? F prime of x, then it is plus your h squared over factorial f double prime of x. That is Taylor. Don't confuse it with Maclaurin. Meaning this Maclaurin, where instead of telling you after the term hx cubed, they are telling you h cubed. Are you seeing that? Yeah. You don't confuse it with the Taylor expansion of f of x plus h. Okay? Yeah. Are we together? Yeah. Good. So after you've done that, you know, this is now Taylor expansion of f of h, but you want Maclaurin's theorem. Meaning in Maclaurin's theorem, a is equals to 0. So where there is a, you put 0, isn't it? So it means f of h is going to be f of 0, isn't it? Plus h minus a, it is just h. That is h raised to power 1 over 1 factorial f prime of 0, then plus, this is just h. That is h squared over 2 factorial f double prime of 0. Are we together? Then it is plus, when h 0, so you remain with h cubed over 3 factorial f triple prime of 0. So have you seen the way the Maclaurin theorem has come out? Don't confuse it with the Taylor expansion of x plus h, because we know very well that the Taylor expansion of x plus h will as well gives you h cubed, isn't it? Is that okay? Very good. So after you found f of x, you now come here and you now see what function were we given? Where do we expand the function? We were given tan pi over 4 plus h. So let us move. Where is your tan pi? Can we use this space or the other one? So we have f of h to be equals to tan pi over 4 plus h. The whole of it is f of h, not h plus anything. Are you getting? Don't confuse with the Taylor where you have x plus h, meaning the f of h is the whole of this. The whole of it is f of h. Tuko pamoja? Yes. Just like a case, when somebody tells you to expand f of x plus h is equals to sin x plus h in Taylor series, this one means h and s are two different things, isn't it? But if you are told to expand f of x is equals to sin x plus h, it means the whole of this is f of x. Are you getting that? So like this, it means the whole of this is f of h. I want that. This example was a very good example because it is eliminating certain ambiguity you might have confused with the other series, isn't it? Yes. Are you seeing that, Nani? Are we together there? The whole of it. So this is no longer f of h plus h, the way we were doing the other one, so that you say your x is this, your h is that. No, the whole of this is f of h. Okay? So start. If you differentiate it for the first time, if you differentiate f of h for the first time, if you let what is inside here to be 1, see it to be x. See, it's like you are differentiating tan x. If you differentiate tan x, you get sec squared, isn't it? You get sec squared x, but your x what? Was pi over 4 plus h. Then you differentiate the inner function, you differentiate pi over 4, you get 0, you differentiate h, you get 1, isn't it? Meaning the derivative of the inner function is just 1, isn't it? So we will remain with the derivative of the outer function. Are you seeing how this example is moving? Yes, the whole of this is f of h. Very different from the other cases, okay? Then move to the next one. F double prime of h. If you differentiate this for the second time, what do you get? Chain rule. Look at what is happening here. When you have sec squared pi plus h, this is how you write it. It is sec pi over 4 plus h, the whole of this is raised to power 2, which is written in short like this, isn't it? So if you differentiate the outer function, meaning if this inner function, if you let it to be x, it is like x squared, isn't it? So if you differentiate x squared, you get 2x. Meaning if you differentiate the outer function, you get 2 times 1, isn't it? So you get 2 into sec pi over 4 plus h, then you reduce the power by 1, isn't it? Then you differentiate the inner function, which is sec pi over 4 plus h. Are you seeing that? So if you differentiate this inner function, sec pi over 4 plus h, differentiating sec, you get sec tan, isn't it? Meaning if you differentiate this inner function, you get sec pi over 4 plus h tan pi over 4 plus h. Then if you differentiate the most inner pi over 4 plus h, you get 1. Because differentiating pi over 4 is 0, differentiating h, you get 1, isn't it? Yes. So it means the derivative of sec squared pi over 4h is this, is the outer function gave you 2 sec pi over 4 plus h. That was outer function, isn't it? Then the inner function gave you this, sec pi over 4 plus h tan pi over 4 plus h. Are we together? So in the end, if you multiply, what do you get? You have to do sec times sec is sec squared pi over 4 plus h, then times your tan pi over 4 plus h. Then you move to the last one. This one is very different from the Taylor expansion of x plus h. Very, very different, okay? You move to the next one when you have f triple prime of h. If you now differentiate it for the third time, isn't it? See, that is now what? Product rule, isn't it? That is now product rule. Because here we have 2 sec squared pi over 4 plus h, then tan pi over 4 plus h. So start your product rule. Meaning you can let this your 2, the whole of this part here. The whole of this first part here to be u and that part to be v, isn't it? Isn't it? Are we together? So, because when you differentiate this, you're supposed to get uv plus uv. So if there is u prime, there is v prime, isn't it? Are we together? So start. When your u is 2 sec squared pi over 4, what is the derivative of sec squared pi over 4? So we found the derivative of sec squared pi over 4. So which is this, isn't it? Then you multiply it by 2, isn't it? Are we together? So let us write them down here for you to see clearly. If u is 2 sec squared pi over 4 plus h, then what is u prime? If you differentiate sec squared pi over 4 plus h, this was sec squared pi over 4 plus h. When we differentiated, we got this, isn't it? Yeah. Then you multiply by that 2, isn't it? If you multiply by that 2, it becomes 4 sec squared pi over 4 plus h. We are done with u prime. Go to v. You have your v here. Look, is tan pi over 4 plus h, isn't it? What is v prime? You differentiate tan sec squared, you get sec squared pi over 4 plus h. Then you substitute u prime times v. U prime times u prime is this times v. You get 4 sec squared pi over 4 plus h times v is tan pi over 4 plus h. Then it is plus v u prime, u v prime, isn't it? U is 2 sec squared pi over 4 plus h, then times v prime is, so it is going to be sec raised to power 4. Sec squared is sec raised to power 4 times this 2, isn't it? So it is plus 2 sec raised to power 4 pi over 4 plus h. Ladies and gentlemen, we've dealt with it accordingly. So you see, this is Maclaurin's. If it was Taylor, the work was very easy. We were going to put it to be x plus h, isn't it? But because it is Maclaurin is combining the whole of it to be one thing. Are you getting the difference? Taylor was going to put it to be x plus h, isn't it, Nani? Yes. But Maclaurin is combining the whole of it. Are you seeing the difference? Very good. You have to note that difference, okay? Very good. So, let us start substituting. What is the value of f of 0? So let us start. Where there is h, you put 0. Because when you put 0 where there is h, you are going to get f of 0. Are you seeing that? Are you getting the argument? You are looking for f of 0, you are looking for f prime of 0, you are looking for f double prime of 0, you are looking for f triple prime of 0, isn't it? So it means, for you to get f of 0, it means where there is this h, you put 0, isn't it? So if you put 0 there, what do you remain with there? If there is 0, you remain with tan pi over 4. So what is tan pi over 4? Pi over 4 is 45 degrees. So if your calculator is in D, you are looking for tan 45 degrees. If your calculator is in R, you are looking for tan pi over 4. You get? That is not it. That is not tan pi over 4. With me, I'm seeing it with a special angle because I'm using the special angle. I'm seeing 1 over 1, opposite over adjacent, which is 1. What have you found? This one. Good. Then you move to the next one, f prime of 0. So here we have f prime of h, meaning when they say you put 0, isn't it? So if you put 0, you have sec squared pi over 4, isn't it? So if you are looking for sec squared pi over 4, this is what it is. It means it is sec pi over 4 which has been squared, isn't it? But sec pi over 4 is 1 over cos pi over 4 which has been squared. Then you get the answer to be 2. That one can be seen very clearly, isn't it? That is what you found. What have you found? This is direct. Because if you have 2, isn't it? When you put, where there is h, if you put 0, you make sec squared pi over 4, but squared is factorized outside like that, isn't it? Then sec pi over 4 is 1 over cos pi over 4, but 1 over cos pi over 4 is root 2. Root 2 squared is 2, isn't it? Good. Move to the next one. F double prime of 0. Where there is h, you put 0. You get tan pi over 4 to be 1, isn't it? Then sec squared pi over 4 we found is 2. So it is 2 times 2 times 1. You get the answer to be 4, isn't it? Ladies and gentlemen, move to the next one. F triple prime of 0. Where there is h, you put 0, isn't it? So you get sec squared pi over 4, we've already found is 2, isn't it? Tan pi over 4 we found is 1. So 1 times 2 times 4, 8. Meaning this first part is 8, isn't it? Then it is plus sec pi of 4 was 2. When it is squared again, it is now 4. When it is raised to power 4, see, it means it is that root 2 raised to power 4. See, that is 2 squared. See, that is 4. 4 times 2 is 8. 8 plus 8, isn't it? 16. Come here and substitute everything. F of h, what was f of h? Where there is f of h, put the value of f of h. What was f of h? Tan pi over 4 plus h. So this question was said to confuse those who did not understand the concept in Maclaurin and Taylor, isn't it? But if you understand the concept in Maclaurin and Taylor, then you cannot have a problem with this, okay? So go to this one. What is f of 0? This is 1, isn't it? So it is 1. F prime of 0 is 2, isn't it? Are we together? So 2 times h raised to power 1 divided by 1 factorial, so you just get plus 2h. Then you move, what is f double prime of 0? Is 4. So 4 divided by 2 factorial, 2 factorial is just 2. 4 divided by 2 is 2, isn't it? 2 times h squared, 2h squared. Are you seeing that? Move to the next one. F triple prime of 0 you found is 16. 16 divided by 3 factorial. 3 factorial is 6, isn't it? 16 divided by 6? 8 over 3. 8 over 3. Decimals? 2 point. So it is plus 2.667. Then it is times h cubed, isn't it? So as you see, we found the Taylor, the Maclaurin series expansion of tan pi over 4 plus h. Maclaurin, it is ascending powers of that variable. If the variable is h, it is ascending powers of h. Are you seeing that? Very different from Taylor. You've seen the difference. You've seen the difference. If it was Taylor, it was going to be tan x plus h, isn't it? If it was Taylor. But if it is Maclaurin, Maclaurin is taking the whole of that to be one thing. Are you seeing that? Very good. So from there, we've now told to evaluate the value of tan 46 degrees. So when you're looking for tan 46 degrees, and you know this is tan pi over 4 plus h, so what do you see here? What is 46 degrees? You start from there. Let me write it here. The first part of that 46 degrees must be pi over 4, isn't it? That first part of that 46 degrees must be pi over, and you now know pi over 4 is 45 degrees, isn't it? So when you are given tan 46, this is now how you write it. Tan 46 degrees is now going to be tan 45 degrees plus 1, because 45 plus 1 degrees, because 45 is pi over 4. Are you seeing that? So from here you convert. So this is tan, you know 45 degrees is 45 pi divided by 180. You get pi over 4, isn't it? Then it is plus, change 1 degrees. Everything must be pi radians. Is when you can evaluate it, isn't it? What is 1 degree in pi radian? 1 times pi divided by 180. 0.0174. 1 degree times pi divided by 180 degrees. 0.01745. So you can see this is now in the form of tan pi over 4 plus h. So you can see your pi over 4 is just pi over 4 the way it was. So this is the value of h, meaning where there is h, you are going to put this value. Are you seeing? Yes. So this implies that h is equals to 0.017445, isn't it? So when you are looking for tan 46 degrees, where there is h, you put 0.01745. So you are going to have 1 plus 2 into the value of h, then plus 2 into the value of h squared, then plus 2.667 into the value of h cubed. What do you have if you do that? If you substitute the value of h, what do you have? What do we have? 1 point into 5 decimal places. 1.035 into 5 decimal places. 1.3552. So that is the value of tan 46 degrees. So can you confirm with the calculator tan 46 degrees? When you are confirming tan 46 degrees, meaning the calculator must be in D, not R, for pi radians, isn't it? So what is tan cos 6 degrees? Is it something close to this? Because this is the approximated value, isn't it? Very good. Are we together? Very easy. So I insist, never confuse. Just because you see pi over 4 plus h, don't say it is tan x plus h. That is Taylor series. We are dealing with the Maclaurin series. Maclaurin series is seeing the whole of this thing to be one thing. Are we together? Yes. Is that okay? Very good.